Well, good afternoon. Thank you all for joining us today for the Iowa Learning Farms virtual field days, where we're going to be talking about increased water quality through water quality enhancement wetlands and oxbows, adding to both water quality and wildlife habitat. Thank you to everyone who's participated in a previous virtual field day. We really appreciate your feedback as we improve these virtual field days as we go along here. And being in the field, our speakers have an opportunity to use their surroundings to come up with ideas that they may not address if they were just using a PowerPoint. So again, we've got some great videos, footage to share with you from wetlands from across the state. But before we jump in too far, I should introduce myself. I'm Liz Ripley. I'm the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. We are based on campus at Iowa State University, and we were established in 2004. Our goal is to build a culture of conservation, working with farmers and landowners, researchers, and scientists to implement practices that improve water quality and soil health while remaining profitable. Events like today are made possible through our partnerships, which include the Iowa Department of Agriculture and Land Stewardship, USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, the Leopold Center for Sustainable Agriculture, the Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, Growmark Inc., Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So I do ask that you remain muted and your video cameras off while I'm playing the videos, but then once these videos are done playing, you'll be invited to submit your questions via the chat directly to me, and I'll get those asked of our speakers, or you can also unmute and ask your questions directly to our speakers. So we have a series of 4 videos for you today. I'll play a video and then we'll open it up for discussion, play a video, open it up for discussion, and so on. Following today's event, you'll be getting an email that'll have a brief evaluation. We do appreciate that you fill that out online and send that in, as well as a recording for today's virtual field day. So if you know someone that wanted to attend but couldn't make it, you can share that link with them. So we've got a great lineup for you today. We're going to kick things off with Dr. Kay Stefanik, the Assistant Director for the Iowa Nutrient Research Center. Then we'll hear from Dr. Matt Helmers, Director of the Iowa Nutrient Research Center. Turning it over to Casey Judge, the Environmental Specialist Senior with the Iowa Department of Agriculture and Land Stewardship, and wrapping things up with Dr. Adam Janke, ISU Extension Wildlife Specialist and Assistant Professor in the Department of Natural Resources, Ecology, and Management. So as we're going along today, if you find yourself as a landowner here in Iowa interested in a wetland or an oxbow, feel free to submit your name, email, or phone number to me in the chat, or you can send a note to me at that email address, and we'll help connect you with the Iowa Department of Ag and Land Stewardship. So without further ado, let's visit our first site in Oxbow.
I'm Kay Stefanik, Assistant Director of the Iowa Nutrient Research Center. Today we are at an oxbow wetland. This particular oxbow is at Chautauqua Bottoms Greenbelt in Polk County, Iowa. The wetlands at this park are mostly oxbow wetlands that are either preserved or restored oxbows. Now, when I say an oxbow, I'm talking about a wetland that is associated with a river system. Now, oxbows are old stream channel meanders that have gotten cut off from the main river channel. This is either a natural process where the river slowly moves over time and the oxbows get cut off, or it can be a man-made process. Now, oxbows tend to be slow water habitats. They are backwaters along river systems. Because they are slow-flowing habitats, they are considered wetlands. Wetland is an area of land that has either standing water or saturated soils long enough through the growing season to support the development of things like hydric soils, as well as hydrophytic vegetation, vegetation that's adapted to a wet environment. Oxbows provide a variety of ecosystem services. Now, ecosystem services are the direct and indirect benefits that these wetlands provide to humans as well as to nature. Some of these ecosystem services include floodwater retention, wildlife habitat, as well as nutrient reduction. Now, with most oxbows, one of their main features is that they help to store floodwater on the landscape. So under normal stream conditions, many oxbows are cut off from the main channel. They may even go dry during drier parts of the year. Whenever there is a storm event, you're likely to see an increase in the level in the river. When the water in the river increases to a certain point, it will overflow its banks and flood into the Oxbow Wetland. This floodwater ends up being retained in the Oxbow for an extended period of time, where that water is then slowly lost to things like evapotranspiration or infiltration into the soil. Now, our next ecosystem service is wildlife habitat. Oxbow wetlands are somewhat unique for wetlands. Many wetlands don't actually have a lot of fish in them, if any fish at all, whereas oxbows, because of their connection to the river system, will typically have fish in them. Whenever floodwater in the river rises, spills over its banks, and ends up in an oxbow, it's taking whatever's in that water with it into the oxbow. This can be nutrients, sediments, but also organisms that are in the water column, including fish, things like Topeka shiners, minnows, and other small fish. Now, while oxbows are important fish habitat, they also provide habitat for a variety of other types of wildlife. This includes amphibians, reptiles, mammals, and birds. All of these organisms will use oxbows for things like general refuge, for feeding, as well as for breeding and spawning habitat. The third main ecosystem service of oxbow wetlands is their ability to improve water quality. When I mention water quality, I am talking about helping to reduce nutrient load as well as sediment load in the water column. Now, when river water gets into these systems, the slow flowing nature of oxbows allows sediments, particles to settle out of the water column. That's the main way that oxbows help to reduce sediment load, is just through settling out. It's also how they help to reduce phosphorus levels. Phosphorus typically is bound to sediment, soil particles that are suspended in the water column. When these particles settle out, they settle out the phosphorus as well. They're also capable of reducing nitrate levels. Nitrate reduction occurs through a process called denitrification. Denitrification is when microorganisms take up the nitrate that's in the water and use it for an energy source and release nitrogen gas as a byproduct. This nitrogen gas leaves through the water column and ends up in the atmosphere, effectively removing nitrate from the water. Due to their position in the landscape between river system and upland areas, oxbows tend to fill in over time. They fill in with organic matter, so dead vegetation, leaves from trees, as well as soil that comes from upstream, as well as sediment that comes from the river system. As oxbows naturally fill in, they'll start to shift to more of an upland habitat. Now, there's been a push in Iowa to increase the number of oxbows through restoration. This restoration process is relatively simple. It's a matter of digging out or dredging out that fill material down to the point where you reach the original river channel. Oxbows can be restored for their wildlife habitat, as well as their floodwater retention capabilities and nutrient reduction capabilities. In areas where there's agriculture, we have a practice called multi-purpose oxbows. Multi-purpose oxbows are an approved nutrient reduction practice in the Iowa nutrient reduction strategy. The way these multi-purpose oxbows are restored is similar to how you'd restore a natural wetland. You'd go out and you'd dredge up the fill material, but then you'd also route a drainage tile line into the oxbow wetland. So instead of the oxbow only receiving water from the river system, it's also receiving water from the subsurface area underneath row crop acres. With this subsurface drainage water being routed into the oxbow, it's also bringing dissolved nitrate in with it. This dissolved nitrate then interacts with the microorganisms in the soil, where it's converted to nitrogen gas, effectively removing and improving the water quality in the wetland.
All right. So again, we have Dr. Kay Stefanik with us today. So if you have questions for her and oxbows, feel free to submit those in the chat or go ahead and unmute to ask them. We have had some questions come in. First off, Kay, are all oxbows suitable to be engineered to enhance their water quality benefits?
I think if you're talking in terms of nitrate removal from tile lines, if you have an area of agricultural land that already has that tile drainage, it's going to make it easier to route tile line water in for nitrogen reduction. In terms of the actual construction of the basin itself, there's not really much you have to do to enhance the nitrate removing ability of the wetland. As long as you have kind of nice saturated soil, standing waters for a decent amount of time, when you want that denitrification to occur, those denitrifying bacteria, they're going to be there. They're going to be in the system and they're going to respond and take up that nitrate. So there's not really much you have to do on the construction side.
And out of curiosity, what's the effectiveness or the nitrate reduction that we're seeing out of these enhanced oxbows?
Nitrate reduction is going to vary depending on the specific wetland, but we can get about 50% on average nitrate reduction from these systems.
Someone's curious in how far the land or the oxbow is from the river. Like how far apart can they be to create that oxbow and keep its connection?
I wouldn't say there's a set distance. You do want to have it relatively close. You'll want the oxbow to be within the floodplain. So as long as it's in the floodplain, you may get some connection, but I'd say the closer you can have it to the river, usually the better.
And is there any concern that these sites would fill up with that sediment quickly during flooding events?
It's really going to depend on the area of the state you're in and how much sediment load is in that river. There is the potential that these fill up. They do naturally fill up over time, but I'd say it's relatively simple compared to maybe other wetland construction projects to go out and dredge these oxbow systems. So yes, they may fill up over time, but I'd say it's going to be an extended period of time. So it's not a matter of years, it's going to be a matter of decades or longer that it'll take for them to fill up.
So I know we have some folks from outside the state of Iowa, so they're pleased to hear that they are now added to the nutrient reduction strategy. Do you have a good count of how many creditable oxbows that have been either restored or exist here in Iowa?
Okay, with the that are specifically associated with the nutrient reduction strategy, I'm not sure if there's actually design criteria in place yet, especially for things like state, federal funding. I know in Boone River watershed, there's been a big push to put in these oxbow wetlands. Right now, they have 32 oxbows, these multi-purpose oxbows that have been either completely restored or near completion within, I believe it's 4 or 5 counties, with more in the works. And I know we've had them constructed throughout the state, but I don't have an exact number.
And just a plug for those of you that are here in Iowa, we do have a field day coming up at one of those restored sites near Laverne on November 10th. So you can find more about that on our events page. So I'm going to go ahead and share my screen again to get to our next video. I know, keep those questions coming in. We'll have time at the end to get to those that I didn't get to just yet.
Hello, I'm Matt Helmers with Iowa State University, Director of the Iowa Nutrient Research Center and Professor in the Department of Agricultural and Biosystems Engineering. Today we're out at one of the Iowa Conservation Reserve Enhancement Program wetlands. This is a program partnership with the Iowa Department of Ag and Land Stewardship and the USDA Farm Service Agency. So it's just a program in Iowa that has been specifically used to put in wetlands at the exit of watersheds, primarily in our tile drained land where we can intercept that tile drainage. And this technology has been around for almost 20 years now. And in fact, this summer in 2021, the 100th prep wetland in Iowa will be installed. And so these wetlands are primarily, at least from the water quality standpoint, they're primarily beneficial for nitrate reduction. And so we have nitrate coming in the drainage water coming into the wetland. We get denitrification within the wetland, and we have lower nitrate going out. One of the great things about this project is that right from the start, it's been monitored. A number of them, a subset of the wetlands have been monitored. Dr. Bill Crumpton at Iowa State University, his research group does that monitoring. And so they sample the flow, or they measure the flow and sample the water coming into the wetland. And then they do the same at the outlet of the wetland. And they've seen that if that wetland pool in Iowa, if that wetland pool is about 1% of that contributing watershed area, they'll see about 30 to 70% of the nitrate removed when it goes downstream. Now, how much removal is going to depend year to year. In a wet year, more water coming in, less residence time of that water in the wetland. We're probably going to remove less percentage of the nitrate, but more mass removal because there's overall more load of nitrate coming in. In a dry year like 2021, there's not going to be much flow coming in, but that flow that does come in, we're going to remove probably almost all of that nitrate. As I said, this has been around 20 years. There's a pretty good data set on the performance of these for nitrate. We wouldn't expect them to be kind of a big workhorse for phosphorus because you may get some sediment deposition and some phosphorus deposition, but in certain times of the year, you might also get some phosphorus release from the sediments in the wetland. So I think Dr. Crumpton would say can't really count on those from a phosphorus reduction, but can be very effective for nitrate reduction. As an engineer, I'm interested in kind of the design of these systems and how we might design them to enhance their water quality performance, how we design them so that we can minimize the maintenance over time with the structures that are put in place. But it's also been exciting to see some of these develop and really appreciate the beauty that they provide on the landscape, the habitat they provide on the landscape. There's something pretty peaceful about being out on this wetland for sure.
All right. So, a couple questions for you, Dr. Helmers. What's the role of the vegetation in the nitrate removal?
So that's a great question, and I'll have to say this is from listening to folks like Dr. Crumpton and Dr. Stefanik talk about this, but the vegetation may not play a big role in the denitrification. A lot of that is, and most of that is happening at that interface between the soil and the water column. In some cases, though, that vegetation could help make sure that we have nice diffuse flow and that there's not concentrated flow maybe down the center of some of these wetlands if they've been put in over an old stream channel in some places.
So, question, after the nitrate has been removed from the wetland and cleaner water flows downstream, what happens to the nitrate at that point? So I know Kay kind of illustrates that, but can you also elaborate on what's happening in that Krupp wetland?
It's, most of that nitrate is converted to dinitrogen gas. Certainly if you there's ongoing work to understand how complete the denitrification is. If you listen to the webinar from yesterday with Dr. Sarah McMillan, some discussion about that, but most of that is going to be released as dinitrogen gas. So we get the conversion of the nitrate into gas form, and we want to get it all the way to dinitrogen gas, complete denitrification, rather than incomplete denitrification, which could lead to some nitrous oxide emissions.
Question is, how many of these wetlands will be needed to make a difference in terms of water quality?
Yeah, that's a great question. And as we look at it, we're really looking at thousands of these types of wetlands. If we wanted to, one example scenario in the Iowa Nutrient Reduction Strategy non-point source science assessment was that we might treat 7.5 million acres with wetlands. That's not 7.5 million acres of wetlands, but 7.5 million acres treated by something like wetlands. Ultimately that could be the wetlands like like we showed right there, or Oxbow Wetlands, or maybe floodplain wetlands, but treating 7.5 million acres with that, if each of those wetland treated 1,000 acres, that's about 7,500 of those types of wetlands.
So someone was noticing that the water in that wetland looked really green. Can you speak on that?
Yeah, and this is where I'm gonna ask Dr. Stefanik to help me out here, because I think some of that may be duckweed on there, which would not be which would be okay. So she's the wetland ecologist. I'm going to let her answer the tough. So I'll answer the easy questions. She gets to answer the tough ones. No, sorry, but I won't. Okay.
The vegetation on there, the green on the water, that was a lot of duckweed. And that's a plant. It's a very small plant that has maybe 2-3 tiny leaves, and then has a couple of hair-like roots that extend into the water column, like barely into the water column. There was a little bit of algae. It didn't look like there was anything particularly bad. It's things you'd normally find in a wetland. And it's very common to see that greener looking water because of that algae and duckweed in wetlands. They are typically eutrophic systems, meaning they tend to have higher nutrient concentrations in general, not just these treatment wetlands, but in general, wetlands tend to have higher nutrient levels, so you get more of that productivity.
Excellent. So I think you answered one of these other questions already. So keep those questions coming in. For the sake of time, I'm going to go ahead and keep playing our next video featuring a farmer who's implemented one of these treatment wetlands.
Hello, my name is Heath Stoll, Nutty Farmer Chestnuts, and we're standing here on my Crepe wetland site today. I guess water quality has been a big topic in the state of Iowa for a long time, and I saw an opportunity on my farm to take out some of the less productive acres and put this Crepe site in. The watershed here, where the Crepe wetland that drains into here, is 1,900 acres. So we captured a lot of water that runs through here anyway. We'd get some flooding and some crop damage. So we saw the opportunity to go ahead and make a Crepe site and do some good for water quality and make an excellent place for wildlife habitat. You get started and you contact idols and you go through a process, and they do all the engineering and see if the site specifics are going to work, the topography of the land. It takes a little bit of while. You gotta have a little bit of patience. There's a lot of things in the background that are happening that idols are doing. Then once you sit down and have the meeting and they show you kind of what it's going to look like, it's a good process. It was very easy. We all got to do our part. With the nutrient reduction strategy, it's going to take thousands of these Crepe wetlands across the state of Iowa to get to that goal. So if you have a spot, it's wet, or you have a small stream coming in, you have, watershed tile lines coming in, contact idols. They'll tell you whether it's going to work or not, and they'll work with you. But we got to have more of these on the landscape that are just super efficient at reducing nitrogen from the water and phosphorus and other things that come from our tile lines. We're putting it on. We need to do more to take it back out, and they're great pieces on the landscape for habitat. Ducks, trumpeter swans, insects, frogs. They're just swarming with wildlife. In the background here, you obviously see the Crepe wetland site, and here's one of the tiles that comes out of my field. This drains probably 50-60 acres up here, so it comes right in. This tile was dumped in the creek over there a ways, so then they rerouted this tile and built it up. Part of the Crepe wetland sites is you cannot inundate any water in the tile lines, so they engineer everything. They raise the tile lines up, they redo them, so it doesn't affect water flow out of your tiles, but you're just capturing it. and slowing it down so that the bacteria in the wetland has time to take those nitrates out of the water before it goes downstream. I worked with U.S. Fish and Wildlife Services. Derek Wiseman flew and through their partners program and got a wetland seed mixture. So seeded around the whole edge of the wetland to try and make better emergent vegetation and food sources for the waterfowl and pheasants. You can see here that there's some water plantain coming, there's some duck potato coming, we got manna grass and slough grass coming in here, so it's really going to make a nice lush emergent vegetation around this wetland, which will also help take up some of those nutrients out of the water. If anybody's interested, they can feel free to contact me if they have questions. I'm always more than willing to talk about it, talk with landowners. This site's great. It's a win-win for everybody.
All right. So there was a question about, while Casey is getting her presentation prepared to share, the Iowa Department of Land Stewardship, question about the role of vegetation and carbon sequestration there, Matt.
Yeah, and that's a good one. We those that were on heard Dr. Sarah McMillan talk a little bit about that, about some of the work that they're doing in Indiana, looking at that, and that there may be some role of vegetation in enhancing carbon sequestration, also in perhaps impacts on methane emission or denitrification a little bit as well. So that's I think that's an area to be looked at. One of the things I think they found was the most incomplete denitrification and some of the worst conditions with reed canary grass. So that may also be indicative of maybe not completely inundated conditions in the wetland as well. But that webinar should be up within the next couple days as well on the Iowa Learning Farms website. So folks can go back and watch that if they want.
All right, so all right, looks like Casey's getting her presentation ready to share here. Welcome, thank you.
Yeah, good afternoon, everyone. Thank you. Is my PowerPoint being shared right now?
It is not currently, but I do have your slides. There we go.
Perfect. Okay, good afternoon. My name is Casey Judge. I'm with the Water Resources Bureau within the Iowa Department of Agriculture and Land Stewardship, Division of Soil Conservation and Water Quality. I appreciate you all having me here today, and I'm excited to share a little bit of information in regards to the funding of the wetlands that you've been hearing about through the previous talks here. So Dr. Helmers touched on this a little bit, but one of the strengths of the nutrient reduction in wetlands that we establish is that they have been backed by research from the very beginning. So thanks to the long-term monitoring that is conducted by Iowa State University. In order to maximize nutrient reduction benefits of these wetlands, they're strategically placed and designed to intercept agricultural drainage water without impacting the drainage rights of adjacent landowners. We do work directly with private landowners like Heath Stoll, who you just heard from in that video, and our programs are 100% voluntary. So our funding is legislatively allocated. The Iowa Conservation Reserve Enhancement Program was established about 20 years ago, with the first wetlands being constructed in 2003. That program is allocated about $1 to $1.5 million annually from the Iowa First Fund, and that's leveraged with federal funds at about a 2-to-1 ratio. CREP wetlands are geographically limited to the 37 eligible counties that are surrounding the predominantly tile-drained landscape of the Des Moines Lobe landform region. So that's these 37 counties here. Now, following the publication of Iowa's nutrient reduction strategy, the Water Quality Initiative Fund was established in 2013. WQI funds can be used statewide, but they are targeted to the 9 priority watersheds that were identified in the nutrient reduction strategy. Then in 2018, Senate File 512 added an additional $15 million annually for water quality infrastructure. So in less than 10 years, we've seen a 10-fold increase in funding allocated to nutrient reduction infrastructure in support of Iowa's nutrient reduction strategy. And we're really excited to ramp up the number of sites that we're able to build each year. So no program is an island though, and we are proud to collaborate with a number of partners on these projects. Iowa CREP is a partnership between IDALS, the USDA Farm Service Agency, ISU, and local SWCD. We've also secured grants through the US EPA Gulf of Mexico Division, and WQI and SF 512 funded sites can be used to pilot innovative design solutions for wetlands and challenging landscape positions. So the oxbows that we're now able to include the multi-purpose oxbow under the nutrient reduction strategy. The WQI and SF 512 funds can be used to fund those kind of innovative pilot projects such as those. We can list over 250 partners that have contributed either financially or through other means. And we are always thankful for the support that we get from others because it enables us to do much more than we could do on our own. So thank you to all of our partners. As I mentioned, our programs are 100% voluntary. So a major strength of wetlands for nutrient reduction is their long lifespan. Most of these have a design life of about 150 years. So that also means that participating landowners are making a multi-generational decision to retire agricultural land. That's a big decision. We offer incentives for landowners that include 100% cost share for the construction of the wetlands. We also offer an upfront incentive payment for entering into either a 30-year or a permanent easement. And if they're funded through the Iowa CREP program, they're also enrolled in a 15-year enhanced CRP contract, and that's at 150% of the average soil rental rate. To wrap up, I'd like to just share an overall summary of our completed projects, and this is outdated. So you can see this map was put together almost a full year ago. So since it was created, several more sites have entered into the design phase. 7 more are wrapping up construction. That includes the 100th CREP wetland that was celebrated back in September. 2 of the wetlands that are wrapping up construction are pilot drainage water recycling sites, and 3 of them are funded by CREP. So based on the monitoring conducted by ISU, the 99 CREP wetland sites that are shown on this map are effectively treating over 125,000 acres and removing over 1.5 million pounds of nitrogen every year. With an estimated nitrogen removal efficiency range of about 40 to 70%, this is equivalent to retiring 50 to 88,000 acres of row crop. So they're definitely doing more than their fair share as far as the amount of land required in order to see the benefit. The facts that just kind of scrolled up on the screen there, I had already gone over them a little bit. The average nitrogen removal cost is about 23 cents per pound there. And with that, I will open up to any questions.
Great. And I just want to direct people to, if you have specific questions or are looking for more information for funding in particular, Jake Hansen from Iowa Department of Ag and Land Stewardship did our webinar on October 13th. So you can find specific details about the programs there as well. But we did have a question come in and maybe Matt or Kay can jump in as well on this one. Regarding the research backing wetlands, what are the lifespan generally? And do you see these wetlands become as nutrient sinks, flipping to become nutrient sources?
Yeah, so the design life, like I mentioned briefly, is about 150 years on that. There are years where, depending on mixing characteristics and things like that, they can become a source for things like phosphorus. Their nitrate removal, however, is definitely a sink. So they take it out of the water completely and move it up into the atmosphere there. So you don't have the same issues as you might with phosphorus and mixing characteristics in certain years there.
Casey, just to add, I think when you say the 150-year design life, that's based on kind of the estimated time for them to potentially fill with sediment. So it's not based on that after that point in time, they wouldn't remove nitrate. So yeah, and that's so one of the challenges with phosphorus is that we can't convert it to a gaseous form like we can with nitrogen. And so it may end up being a sink at certain times and then a source at other times, depending upon the flow rate and the characteristics of the water coming in. And that's why I think if you listen to Dr. Crumpton talk, he'd say we can't really rely on wetlands for phosphorus reduction. And that's why if you look at the Iowa nutrient reduction strategy, non-point source science assessment, wetlands are not listed under the listing of phosphorus practices.
Casey, someone was curious if there's funding available for oxbow restoration.
Yes, that can be funded through, I believe, WQI and SF 512 right now. I'm not certain about CREP.
Okay.
I would have to check on that.
Someone is curious, you mentioned the WQI priority watersheds. What benefits do they receive as being priority watersheds?
So those would be the targeted areas for nutrient reduction wetlands to be installed and other nutrient reduction infrastructure. So the funds can be used statewide, but we target those watersheds because they were the highest priority identified.
And so if someone's not in those 37 counties and they have a question, which ones should they go in and ask about because they don't qualify for CREP?
If you come into any of the field offices or anywhere that you would reach out to conservation assistance or your local FSA office, and you mentioned that you're interested in nutrient reduction wetlands, they will direct you to the appropriate person to talk with there. And once we know that you're interested, we can definitely talk with you, look at your property, see what types of practices might fit. We're interested in getting the practices on the ground, and we can sort out which program that can be funded under later, depending on the site characteristics.
A question here. Has anybody thought about using floating vegetation mats used in urban stormwater ponds for phosphorus removal, especially dissolved P?
I am not familiar enough with current research on those types of practices.
Yes, same here. There was actually some work a number of years ago with floating wetlands on Lake Laverne here at Iowa State University, but I'm not sure what the ultimate outcome was from that, or whether that got published.
Jackie here, we have a webinar on this, our urban conservation. He did wetlands and he talked about some of these types of projects.
Cool.
So I can't remember the exact webinar that is, but it would have been a couple of months ago.
Was that Bill Hunt?
Bill Hunt.
North Carolina. Yep, from North Carolina. Great. Okay.
Coming up again on November 10th.
He's doing another one on November 10th. All right.
All right. So yes, if you're, as Heath mentioned in his video, if you want to reach out to him for questions, the best way to find him is just search for Nutty Farmer Chestnuts on Facebook, and send him a message there. He is doing some really unique things on his farm. So thank you, Casey. We'll hold on for more questions here in just a bit, but we're going to show our last video starring Dr. Adam Jenke.
Hi, I'm Adam Jenke. I'm the Extension Wildlife Specialist at Iowa State University Extension and Outreach. I'm also an assistant professor in the Department of Natural Resource Ecology and Management. Really excited to be speaking today on the site of this beautiful wetland restored through the CREP program in Iowa, the Conservation Reserve Enhancement Program, that looks to target wetland inside watersheds to treat drain tile and remove the nitrates in the surface waters. As a wildlife ecologist, I'm of course interested in removal of nitrate from surface water because of its positive impacts on downstream wildlife habitat and water quality. But I'm also really excited about wetland conservation practices to address water quality because they create a lot of secondary benefits, namely related to wildlife and wildlife-associated recreation, like we can see on this beautiful parcel here. In Iowa, over 120 different species of birds, fish, mammals, reptiles, amphibians, butterflies, other insects are listed as state species of greatest conservation need that are reliant on wetland ecosystems. So we know as we put wetland ecosystems into Iowa's landscape to address challenges related to nitrates in surface water, we also are at the same time addressing challenges related to declines in many of Iowa's wildlife, from everything from butterflies to beautiful birds. There's also over 300 different species of plants uniquely adapted to wetland ecosystems in Iowa. Many of these plants are rare, declining, and many wildlife species rely on these plants found in Iowa. Here at this wetland, we find a bunch of different wetland plants, both out in the water itself, in the wetland, floating on the surface of the wetland, and then along the margins of the wetland as well, and then even into the uplands. And that's another exciting thing about this conservation practice is not only is it putting wetland pools out onto Iowa's agricultural landscape, but it's also creating wetland or adjacent upland habitat that's really important, that interface between terrestrial and aquatic ecosystems that creates even more wildlife habitat and also is another way to improve water quality. One of these plant species that we find on the margins of Iowa's wetlands is swamp milkweed, which of course is familiar to anybody in the conservation arena as one of many species of native milkweeds found in Iowa that are really critical to efforts to restore and protect monarch butterflies. And so swamp milkweed is just a wetland version of many different types of milkweeds, and we find that here at this wetland today and also at many different types of wetland ecosystems across Iowa that can help create habitat for the monarch. The list of species that we could find at this wetland is really quite long. Just standing here listening today, I can hear a marsh wren calling to my left, common yellowthroats calling over there, a bobolink just flew over the camera setup, there's dick thistles calling in the uplands, great blue herons have been foraging in the shallower portions of the wetland. Upstream, we've seen mallards and wood ducks, and those are also rearing their broods this time of year because they've nested either in wood duck boxes on the parcel or in the adjacent upland areas and led their young down here to this wetland. In fact, last year during some research that one of my graduate students was doing, where we were visiting wetlands all across Iowa and Minnesota with drones to count young ducklings, we visited this wetland as part of a random sample of wetlands in our study area and found over 60 ducklings were on this wetland last summer. So these wetlands really have a remarkable capacity to contribute to wildlife production in that way. The other exciting thing about wildlife production on wetlands is it provides a lot of opportunities for wildlife-associated recreation. And so we know this landowner is interested in things like observing wildlife on his farm, and then also enjoys hunting wildlife. And CREP wetlands and other wetlands put into Iowa's landscape to address water quality create habitat for humans as well, where they can kayak, bird watch, enjoy time with their family, or go hunting. So wetlands are really a solution that to many different challenges, not just the challenges that we have related to water quality.
All right. So Adam, you mentioned that there was a list of creatures of conservation concern. Where might one find that list if they're curious to see what creatures are on it?
Yeah, so what I was talking about was a designation called Species of Greatest Conservation Need, and that's designated in the State Wildlife Action Plan. So if that's a plan written by a panel of Iowa citizens, actually, and facilitated by the Iowa Department of Natural Resources, and it's sort of a planning document for what we say non-game wildlife conservation in the state. And you can find that with a quick Google search, State Wildlife Action Plan. And those lists of species of greatest conservation need are in the appendix of the plan. And every state has one of those.
So looking at the vegetation that you find at different wetlands, is there something landowners can do if they're looking for a particular species of wildlife to help provide them with habitat?
Yeah, of course there is. Now, the challenge with wildlife is that the answer is different for every species. We can talk in generalizations about certain guilds that respond in similar ways, but yeah, what you would do to manage your wetland to attract Virginia rails, soras, or least bitterns may be totally different than what you would do to attract, oh, I don't know, tree swallows and Canada geese to your wetland or something like that. So it's hard to sort of answer without more specifics on the species, but some generalizations we can draw. We find the most wildlife diversity on wetlands that have interspersed emergent vegetation and open water. This is actually a hypothesis in the ecological literature that was originated here in Iowa, the idea of like a hemi-marsh, which hemi just meaning sort of like halfway, half vegetated and half open water. We find there that the most species of wildlife tend to benefit from those conditions. Another generalization that we could draw is just shallow water foraging areas in wetlands are really important. So like the types of birds that I like to study, ducks, the type of ducks that dabble for their food, called dabbling ducks appropriately enough, can't feed in water any deeper than say 20 centimeters because they're just tipping up or they're just feeding with their bill. And so you could have really good food, say, in a wetland, but if it's 2 feet, 4 feet or more underneath the water surface, then those ducks would never have access to it. And so finding places for like shallow foraging habitat for many different species of wildlife can be really important. And I could go on. I mean, if you had more specifics, because I mean, there's like exposed mudflats are really important for a bunch of species that we call shorebirds that migrate through Iowa. A few of them breed in Iowa, and they probe their bills into the sediment. And so we need exposed mudflats, and we need deep water areas for diving ducks. And I could go on, which I would love to, but maybe there's another question.
Do you see beavers creating troubles within those wetlands, especially the constructed wetlands?
Well, I don't have firsthand experience on constructed wetlands in Iowa to speak to the extent of beaver challenges, but I've spent a lot of time in Midwestern wetlands, and beavers do often create challenges in manipulating water control structures. You know, beavers generally want to stop the flow of water. And so if we're trying to say draw a wetland down for a certain outcome, beavers can sort of get in the way of that operation. So it's not uncommon to have conflicts between human wetland engineers and beaver wetland engineers in wetland ecosystems.
So can we work with them? Can we provide them with an opportunity to help create some of these wetlands?
Working with beavers?
Yeah.
Oh, well, I think that's an awesome idea. You know, beavers are certainly the original wetland engineer, and we find in areas, particularly along rivers and streams, that beavers are, you know, slowing flow, doing the same things that crepe wetlands and natural wetlands do, slowing the flow of water, allowing for the settlement of nutrients out of, or excuse me, of sediment out of the water column, and then also allowing for time for the natural process of denitrification to occur. So yeah, work that beavers are doing where tolerable is really important part of the landscape. Now, the challenge, of course, with beavers is that we don't get a say in terms of where they do their constructions, and that's where conflicts arise. But there's good ways to resolve some of those conflicts to kind of keep beavers on the landscape doing good for water quality, flood control, wildlife habitat, and other ecosystem goods and services that wetlands provide, while also sort of minimizing their damage to like drainage infrastructure, urban like stormwater management infrastructure and things like that. So there's professional wildlife biologists all across the state that can help resolve some of those conflicts too.
So someone's curious, when these wetlands are being designed, is habitat needs being factored into it, and how do they compare to the other goals like water quality?
Well, so I can speak to this a little bit, but I'd love Matt or Casey to jump on and fill in as well. I think there is a tendency, especially if it's a priority for the landowner, to consider wildlife habitat. I know some of the design characteristics in wetlands, like for example, keeping a certain average pool depth is wildlife habitat has certainly been considered there. And then I've seen some sort of creative manifestations of crep wetlands that try to create interspersed emergent vegetation or shallow water areas for birds and other wildlife that have been really cool. And then I saw Casey unmuted, so I want to jump to her. But one other thing I wanted to mention is that we also do a lot of terrestrial wildlife habitat when we do a crep wetland, because all of these wetland pools have a required upland buffer associated with them. And Casey could tell us the programmatic, like how much that number is. The wildlife biologist that's walked around these things can tell you that they're full of a lot of diverse native perennial prairie plants that provide really important habitat for a lot of terrestrial birds, including some of those that I was talking about calling during that field day earlier or the recording earlier this summer. Bobolinks and sedgerins and things like that aren't wetland birds are really benefiting from crep because we're planting diverse native perennial vegetation in the uplands around the pools.
Yeah, I just wanted to chime in and say from a funding standpoint, the water quality benefit is the key thing. So design characteristics are primarily focused on water quality, but as Adam mentioned, we get to benefit from the additional environmental habitat and stuff that we get from them as well. So I've also seen a ton of pheasants in things like that in the upland buffer areas, a lot of like yellow-headed blackbirds, things like that. We see a ton of wildlife out there. The buffer zone is key to that as well. So, yeah.
Hey, Adam, Jackie here. I'm the one who videotaped Heath. Heath actually, the landowner, drove what habitat was going to be on his wetland, working with IDOLs and working with some of the federal agencies too. So also interest in the landowners, they often want to create more habitat because they have certain hunting interests and other things, as well as the water quality issue. As he said, it's a win-win for everyone.
So a question back to you, Adam, as our resident wildlife specialist in the community. When these crep wetlands were first introduced, there was some pushback from wildlife folks. Have they become around to embracing these sites now? Or what do you hear from fellow wildlife specialists?
A range of perspectives and attitudes towards these, I think, is what I would say I hear. I guess to sort of characterize a critique could be that, there's a phenomenon that we call consolidation drainage, where you take many small ephemeral wetlands and use drainage infrastructure to combine them into one relatively more permanent wetland. And then that facilitates farming in the uplands in those new drained areas. And that's a challenge that we face in prairie landscapes, is consolidation drainage, because replacing a ephemeral wetland with a more permanent hydro period. And ephemeral wetland, we mean something that's just wet for like a few weeks every year. with a more permanent wetland, like what we see with the CREP program, isn't like a one-for-one trade. There's different species of wildlife that benefit from those ephemeral hydro periods due to lots of different life history adaptations that I could kind of like spare you the details on, or actually I'd love to share the details with you, but we don't have time for them. And so that's a critique you'll hear among wildlife ecologists. Now the CREP program, of course, is just taking extant drainage water. Like it's not like going into the uplands and doing more drainage. And so that is a critique of like the modern CREP program maybe misses the nuance in that the drainage has already occurred and now we're trying to treat the water in the drainage infrastructure already. But you know, that's a criticism that I've heard that's, you know, worth being aware of, and it's valid, like the issues of consolidation and the loss of more ephemeral wetlands in favor of more permanent wetlands out there. But then others, like, you know, myself included, like are really excited about all the species of wildlife that are benefiting from CREP wetlands. Casey shared there's over 1,000 acres of wetlands on the landscape today that wouldn't have been there otherwise, and that was all motivated by water quality. And we know lots of different species of greatest conservation need, and others are taking advantage of those. So it's kind of, I think, striking a balance. We need ephemeral wetlands and to get certain species of wildlife through their life cycle. And so we're going to need to find ways to conserve those in working landscapes. And then we're also going to need to find ways to integrate wetland conservation into those landscapes to address multiple benefits like water quality, carbon sequestration, flood control, and wildlife habitat.
Adam, do you think, sorry, can I jump in and ask a question, Liz?
Yeah, we've got time for
Okay, I guess I already did. I spoke up. Do you think in these, you know, water quality enhancement wetland kind of complexes, could we design some ephemeral water areas in there as well? That wouldn't be one-to-one, but at least maybe provide a little bit of that habitat?
Yeah, I think that's a really interesting thought, Matt. And yeah, I think so. I've been on a CREP wetland in, I think, Winnebago County that kind of does that. They have like sort of a flat area where there would be more ephemeral hydro periods. The problem, I guess, would be if it were connected at all to surface waters. And one of the biggest things about like ephemeral wetlands is the fact that they don't have any fish in them, and then certain species really flourish in fish-free environments. And more permanent hydro period wetlands tend to have fish get into them in one way or another. And so that's one thing that may be hard to replicate, like on the margins of a CREP wetland. But, you know, we talk a lot wildlife habitat restoration and stuff about wetland complexes where you have like a bunch of different wetlands in the same area. And that might potentially be a design consideration in the future. And then, you know, the business about like tile zone wetlands and like other types of wetlands that are in depressional landscapes that might have more shallow water associated with them, that might also be another way to overcome some of that. And yeah, it's complicated. That's the thing with wildlife. There's, what did I say, 100 or 120 terrestrial vertebrates or vertebrates that are SGCN and use wetlands, something like that. I mean, it's insane. And what's good for you know, what's good for a least bidder and it's not going to be good for a pectoral sandpiper. And like there's challenges in sort of like understanding those varied wetland complexes and getting out of our landscapes what we like, what society values as it relates to wildlife conservation. It's definitely a challenge.
Great. I'm going to share my screen one more time. Again, if you are an Iowa landowner and you're interested in possibly a wetland or oxbow on your land, feel free to email me. My email is there. You can provide me with your name, email, and or phone number, and we'll get you connected with the Iowa Department of Ag and Land Stewardship to pursue that and see if it works for you. This also applies to cover crops too. If you're interested in that, we can make sure that you are aware of their cover crop insurance program, which opens up with sign up in December. And lastly, if you joined today to get your CCA credits, drop that information to me in an email. I'm going to put my email in the chat here so you can get that from there as well. It's ejuchems@iastate.edu. And while we have in-person field days coming up in November, I do encourage you to join us for our next virtual field day, which is scheduled in December, where we'll be focusing on cover crop do's and don'ts, where we're learning about cover crops, corn growth, diseases, and pests with Allison Robertson and Mark Licht. So if you have any last questions, get those submitted. If not, I can also pass them along to the crew here if you have specific questions to connect with something on your property.